Hello, everyone, and thank you all for coming. I'm Danny. I do security at SNCC. And this is Yuval.
And I'm Yuval Ofir. I'm from Clarity.
Cool. And we, both of us are from a team called Pasten. We are a much bigger team than the two of us. And today we're here to tell you some stories about how we started, like about our journey in the CTF world, and share some fun challenges that we encountered. And hopefully encourage you, if Guy didn't do that enough, encourage you to play the CTF next time. So let's start. I guess most of you are familiar with what's a CTF and the different types of CTFs there are, but still kind of doing some quick intro on what it is. So CTF is a security competition, capture the flag. There are basically two types of competitions. One is the Jeopardy style, the other one is attack defense. So a Jeopardy style CTF is when you have, all the teams have a same set of challenges. And so each challenge is a kind of like something you need to solve. And when you do, you get a point. So you submit the flag from the challenge to the portal, to the organizer system, and you get points. So you compete against the team by who solves more challenges. There is no direct, no other interaction between the teams. And yeah, important thing is that you have different categories in the challenges. So you would have crypto challenges, you would have PWN, which is like exploitation, finding vulnerabilities and exploiting them. You would have reverse engineering challenges, and web and miscellaneous, just like weird challenges, like hardware and things like that. And the attack defense CTF has limited number of groups because the thing is that the teams compete one against the other. Each team would have some set of services that they operate, and you would need to protect those services against attack coming from the other teams, and in the same time attack the services of other teams. So that's why in this type of CTF you would have a limited number of teams playing. So now let us share some stories from the CTFs and how we started this journey.
Right. So we're going to talk about three CTF, which are our favorites. Here are the logos. The first one is CCC CTF, the second one is Google CTF, and the last one is DEFCON, if we'll have enough time. So I'll tell you the story behind our first CTF. The few rules about the CCC CTF. It's a Jeopardy style CTF. It's on site, but you can also play it remotely. There are groups that are not doing it from the CCC itself. Sorry, I haven't explained about the CCC. I don't know if everyone is familiar with. CCC is a conference going for like the 35 years in a row in Germany. There are like 15,000 attendees, and it's growing each year. And one event that happens as part of this conference is the CCC CTF. Speak up. Okay. There are no prizes, and it takes 48 hours from the first day at 8 p.m. to the last day at 8 p.m. The only thing we knew when we started the CCC CTF was that the flags look something like that. We were four friends like 5 or 6 years ago. We took vacation days from work to participate in the CCC conference, not even the CCC CTF. And we saw their ads for the CTF, and we decided to sign up and see if we can handle a challenge or maybe two. When the CTF began, we decided to take one challenge to start with. So we just choose the hardest challenge that was on the CTF. We had only 2 laptops, so we couldn't do much more than 1 or 2 challenges simultaneously. But we started from the hardest one. Long story short, 3 a.m. of that night, we managed to be the first team to solve that 500 points challenge. We didn't know if it was good or bad, so we just went to sleep. We said, okay, it was fun. But when we woke up, we looked at the scoreboard and we saw that we're still the only team to solve that challenge. So we decided, okay, maybe we have a chance. We'll take another one, an easier one. So we took a challenge, which we're going to give a short walkthrough called PiXIK.
Cool. So PiXIK was in the category called sandbox, which typically means escaping out of a sandbox. And the difficulty was easy. So that's after that hard one we struggled with, we chose an easy one. So we would get an IP address where we would go and see something like that. This would be the interface. There is an edit box where we could write Python code. And we could press exec, and it would evaluate the Python code. So we knew we need to run some Python code that would read a flag file. And they actually provided us with the Python script itself. So the application itself was available to us. And that's where we could see that they would blacklist all sorts of nasty things we could use in part of our exploit. So not anything you could, anything interesting in Python you could think of, you wouldn't be able to do. And they also had this whitelist. So basically, it would be limited to very specific set of characters that would work. When we played with it, basically nothing worked except for some really basic calculations. Any ideas what we can do here? Well, I hope I heard the answer, but the answer is Python encoding. So apparently, you can start a Python script with the following line, hashtag coding, and then choose one of the following encodings, and then you can just encode your full Python script in one of those codings. So in this case, we could just use the row Unicode escape and taking this simple line of Python code that is opening a flag file and just reading it, printing it to the screen. And this would be encoded into this Unicode escape string. And when we ran it, we would get the flag. So indeed, it was a nice and easy challenge and a really fun one.
Okay, another challenge we solved the same CTF was big data. It was considered harder, and the category is spawn. Once again, we need to execute code on the server. When we got a challenge, the first thing we saw was that meaningful description, just big data, and the file, the targz file containing the binary that the server runs, and an IP address and host that the server runs that binary on. So we took the binary, we started to reverse engineering it and understand what it does. And we found a stack buffer overflow just like in the textbook. They have a buffer with a limited size, that is the size. And they receive the length of the buffer from the user, from us. And then they just read data according to the buffer length that we send. Sounds really easy to exploit for everyone that experience a little bit experience with the stack buffer overflow. Well, he knows what to do. And in order to trigger that vulnerability, all we need to do is just send some data that will be bigger than that buffer. And it worked locally on our machine when we tested it, but we couldn't make it work on their server. The reason that we couldn't make it work was that we couldn't make the receive call, the receive right here, that receive, to return more than 1,500 bytes of data. And the reason that we couldn't make it happen is because there was a really long network between us and the server, and the mechanism that our data was carried on was TCP. TCP is a stream-based protocol, meaning that you don't get to choose which data is being sent in each chunk. You just send data, and the receiver will read it however it wants. And the segmentation is handled by the TCP stack. So if you send a big chunk of data, and there was no network between you and the receiver, then you will receive everything in one receive. But if some network segmented this buffer into smaller chunks, then the TCP stack is allowed to give you only smaller chunks. Another thing to understand about TCP is that it's a reliable protocol. So it must handle retransmission and keep buffers for handling of out-of-order packets. And we will show that in a minute. And we wanted to make sure that we wanted to send some special messages that will make the TCP stack buffer all the data for us and return it in one chunk. So whenever you send a big message, this is our big message, the TCP stack will segment it into 1, 2, 3, 4, 5 chunks and send them in that specific order. But what we wanted to do was we wanted to split the message into those 5 pieces, but send the second message, then the 3, 4, 5 message, and only then we'll send the last message, and the receiver side will understand that here is the complete chunk. Now I will forward it to the application to be processed, and by this, the receive will be in one big chunk. We tried to implement it. In order to do that, we had to implement our own basic TCP stack, and we did it for over 2 hours. It was late in the CTF, and we haven't had much sleep that night. We haven't had almost any sleep that night. So we just couldn't make it work. Any ideas of what to do? Jumbo frames is a nice idea, but it was internet between us and the server, so we dropped jumbo frames. So remember the previous challenge, the PiXIK challenge? We thought that maybe they host the challenges on the same data center, or maybe even on the same server. So we thought maybe we would just run our exploit code through that interface. So exactly just like running our code in here, we put our exploit code in here, and it worked.
Cool. So this wasn't intended, of course, but still we believe it was according to the rules, so that was fine. And by the way, like that year we came in on the 5th place. This is the first time we played the CTF. And the nice thing about it is that this is the first challenge we solved. We are the baby blue chart here. Each step in this graph is a solved challenge. So first challenge we solved was the hardest one, and then we went to sleep. Like no other team did that. Like then we woke up and we seen like, hey, this is nice. We're still kind of leading in the top 10 or something. And then we had some friends join us on site, but also in Tel Aviv, and then we're playing until the end of the competition, making it to the 5th place. So a year later, we really got excited about all this CTF thing, and came back with more people. We were 15 friends on site and 5 more home. We had actually reserved a table, which is a thing you can do in the CCC conference. Before that, we were just kind of homeless and just grabbed some table there. And we had a VPN and a VoIP, so we could actually call our friends, and then like we had real infrastructure. We used Slack, which is today very obvious, but back then most CTF teams had their own custom kind of knowledge sharing and challenge solving systems that they used. But Slack was the laziest thing we could do, and it worked really well for us. Now, this time we also had some AWS machines that we could use for crypto challenges and some other things. And of course, most importantly, we actually got some food and beers, which this is something that we really didn't have last year. And so this is a photo with all the food and the beer and
the VoIP.
Club Mate, yeah, this is the Club Mate, but also had our own beers there, and this is a phone, like a real VoIP between us and the Tel Aviv base. So that year we came in second, and with quite a big gap, I believe. Like there was it was a single challenge, a really fun one, but that's what made the whole difference. And the third year, a year later, we came back, and this time we actually won the first place. And so these are some photos of celebration. But then the year after, we kept the first place as well, and then another year later, we won the first place 3 years in a row. This is the CTF floor from year 2017. This is our team here on the front. So from that year, from 2017, a really fun challenge, which was they gave it a difficulty medium, but I think they regretted it because it was kind of super hard, and it was really interesting. So that's why we'll share some of this now. So we got, like many of the web challenges, you just get an IP address. So we received this IP address where we would go to it, and we would see the secure file extraction service. You can provide it. You can provide it a URL pointing to a zip file, and it would extract it for you and let you download the files from the zip file. Nothing fancy, but there are some things that happen here. First, we've seen that it extracts all the files in a root directory. So if you have some folders in it or some kind of like folder structure, it just ignores it, and all the files fall into a single directory. It supports multiple formats like 7-zip, zip-tar, and probably others. It deletes all the folders and all the symbolic links that you had inside the zip. So it just, again, flattens all the files out, but just the files. And there's some limitation they do. They have like, they limit you not more than 5 files in a zip archive and not more than 10K of data. So you cannot do any denial of service. So first thing we do is create a symbolic link inside a zip archive, and that would point to a root folder. And what we get back is a warning from the system saying that we have detected some folders deleted some folders from your archive, and they use some cyber-enabled filtering system. So this would be a link. So when we click on the link of the cyber-enabled filtering system, we would have this code. This is a PHP code, basically showing us that they traverse through all the files in the zip archive and delete anything that is not a file, basically a folder or a symbolic link. Any ideas how we can bypass the cyber-enabled filtering system? Louder. So the answer is around this function. The glob function, this is like a listing function, but it doesn't take into account hidden files. So anything that starts with a dot wouldn't be captured by the glob function, meaning that all we need to do is create that same symbolic link to the root folder, but this time we can just use a dot in the beginning. And voila, we actually get now to list the root folder, and we can just travel in the file system and find some stuff. So the first thing we find is in the folder of a home folder is a script called create backup of my super secret flag. So this is a script that all it does is reads the flag from the standard input and writes it into the MySQL database. So the flag is not here. We hoped that we will find this flag. Many of the challenges end in this stage. You can find the secret file, you find the flag, and you submit it to the system. Not in this case. We actually see that they just read the flag from the standard input somewhere here. Yeah, from here, and just send it save it into the MySQL database. So this is sort of a hint to us that the flag is stored in a MySQL database running as on the same machine. So we think. So what do we know? We look at and we find another file, index.php. This is the core, like the functionality of the actual challenge. So it does all sort of checks on the URL, basically blocking you from accessing localhost and some weird, other weird things. It gets the content of the file using libcurl. So this is a PHP code, but it uses libcurl to download the file we provided, the URL. It saves it to disk. It checks if the archive is valid and if it's like has less than 5 files and 10K. Extract it, and then we've seen it deletes everything that is not a file. So, so we know that we control the URL. We need to access MySQL server that runs on that same machine. But we see that they block us from connecting to localhost. So basically, what we want is somehow to connect to localhost, run some SQL query, and then get the flag. So we, after a lot of tinkering, we realized this thing. We realized that the library, the libcurl library, treats URLs differently than all the PHP runtime, but also all the other runtimes. So basically, if you take this weird-looking URL and provide it to libcurl, libcurl will take this part. But if you use the URL parsing of any of those runtimes, they would see Google. So that's how we could bypass the first check that prevented us from connecting to localhost, which is like the actual database. So they think we connect to Google, but in reality, we actually go to localhost. So again, this is like we're exploiting a server-side request forgery vulnerability because they fetch the URL we provide. And so, yeah, so in this example, we use this URL. So PHP sees google.com, curl sees localhost. So that's good. Now, as some of you might know, libcurl supports much more than HTTP protocol. They support all those protocols, including a protocol named Gopher. So Gopher is an interesting one. If you use this URL, basically provide libcurl with this URL, what it will connect to localhost to port 3306, and we'll open a TCP connection, and we'll send this data, everything that is after the underscore, the underline, to the server. So basically, they give us a way to connect to a MySQL server and send one packet to that server. And so what we need to do now is to construct that single packet we can send. And we just looked at the MySQL protocol and constructed this thing. Basically, this is the first packet you send to MySQL, which does the authentication. And then we can send the SQL query. So this would result in something like that. What you see here is Gopher. This is the localhost, the MySQL instance we are connecting. This is the port. And all this would include a valid MySQL protocol that would open a connection, do the needed authentication with the username. And then all this part is an SQL statement that fetches the flag. So the tricky part here is that this thing, when we take this and provide it to our servers, the service expects to get a zip file, not a string with a flag. So because the next step that would happen is that this zip file needs to be extracted. So we had to encode into the SQL statement the actual format of a valid zip file. What you would see here is like a PK zip, like it's an actual zip file, and somewhere here would be the flag. Okay, here we can see inside. We would build a zip file and place a flag inside that zip file. So now when we do this, when we provide all this here, what we get is this, is a valid file that when extracted contains a valid, when it's a valid zip, when extracted contains a file named gimme flag, that's how we called it. And when we open the flag, we would get this nice string. And that's the flag we would submit to the system and get some points. So in summary, really also like a lot of credit for the crazy people that created this challenge, because it had so many things in it. It had like you know, the symbolic link trick that we've seen with the dot. It had the inconsistency between the different URL parsers. It had an SSRF vulnerability that you know, we need to exploit it. You need to do this, and there is this funky thing with the SQL. So this was the last, the 2017, I think, and again, this is when we actually won the first place again. Yeah, and this time we're moving to Google CTF.
So Google CTF, once again, Jeopardy style. Today it has 2 stages. The first one is qualifiers, which are totally remote. The top 10 qualified teams will go to an on-site CTF where you are allowed to get assistance from home. And for the first time in our experience with CTFs, we get money when we win. Today we know that it's considered its level, its complexity is pretty high. Google are really good engineers, and they invest a lot of time on those challenges. And we want to talk to you about the challenge called slot machine. This time from a category called hardware or reversing, and
it's an actual challenge. It's a challenge that is actually based on a real story of Russian hackers that found basically a random pseudo-random vulnerability in one of the slot machines in Vegas and in the casinos, and basically used that crypto vulnerability to win some real money. So Google created a challenge based on this story. We didn't know that back at the time, but the challenge, because this was a CTF final, so this was actually on site. So all the 10 teams, the 10 finalists were on site in London. And that's why it was possible to provide each and every team with an actual hardware. So they gave us this little toy slot machine. And the first thing we did was open it up, and we found this chip. And this was an Atmega chip, a microcontroller. That's where they also provided us with some basic equipment to read the firmware from the chip. So we did that, and then we got to the actual firmware. So that's where the reverse engineering part started. And basically, after some reverse engineering, the two kind of interesting things that we found was this two secret kind of key combinations. So if you would, on this screen, let me show you, on these buttons, if you would press the secret combination, you would get to 2 secret screens. First is the debug screen, so we will see it later, what it allows us to do. But the other one is flag screen, which would provide us with the first flag. So when we would press this combination, we would actually get the first flag. It's important to say that while they provided us with a toy slot machine, the actual attacks would be run against a central slot machine. So every team would need to do the reverse engineering to understand the process, to understand the vulnerability, but then they would need to go to an actual central slot machine and execute the attack. So this would help us get the first flag. And on the second flag, I'll let Yuval talk about it.
So on the second flag, when we enter the second code, we get to this screen, which says the developer menu, enter Delta. We try to reverse engineer what it does, and we came into a PRNG mechanism. PRNG is a pseudo-random number generator. I hope you're sitting down. There are no random numbers on cheap microcontrollers. They are actually generated using some short, typically 32 bits, random number that will be generated on the boot time. And since then, they will advance the random state using some simple formula such as this. So we reverse engineer that formula, and we came into conclusion that here, this is the mechanism that, that handles the random number generator for that machine. This is a really simple simulator. This is the random number generator. Whenever you call the rand function, it will just advance the random number generator state, and it will return some part of that state. For the machine to choose which symbols to display, to draw on the screen, it uses that code. It says, okay, if it's above some value, it's a 7. Otherwise, it's a lemon. If it's above some other value, it's lemon. Or otherwise, it's a bar. Those are the three symbols that this machine drew on the screen. What we wanted to do, any ideas, by the way? How to exploit that? Okay. We wanted to play the slot machine 5 times. Why 5 times? Because within 5 times, if we will write down what signs we got on the screen, we will be able to understand where we are in that random number generator state, and we will be able to recover that state. And whenever we recover that state, we're able to understand not only where we are, but we're able to expect the next values that will return from that state. Actually, if you remember the screen, that screen, then the enter delta is basically the machine asking us how many advances of the PRNG state you would like to do. And we could say, okay, instead of like pulling the lever 100 times, we could just write down 100 and it will advance that state for us. So our plan was to understand our current state based on playing the machine for like 5 times. And now when we have the state, we can calculate the distance between our current state and where we want to be, to advance it right to the point where we would expect that 3 times the 7 symbol will get out of the random. And on the next pull of the lever, we will just win the slot machine.
Yeah, you can press and it should play.
Really?
Yeah, good.
I don't think it works.
Yeah, it worked. So basically, yeah, that's where that's after you would enter the delta, and we basically jumped to the place where it's the next play would give you 777. So that's the solution.
And then the flag.
And then the flag. Cool. So that's our Google CTF history. We actually, the first time Google started doing the CTFs were 2016. So that's where we won the first place, and the year after. Then we took the 3rd place, and another Israeli team took the 2nd one. So 5BC is an awesome Israeli team that always gives us a good fight. And this year, this night, we had the qualifiers. So anyone here played the Google CTF qualifiers? Okay, some hands here, cool. So this morning, 3 a.m. this morning, qualifiers ended. So we actually took the 1st place in the qualifiers. All of the 10 teams, I believe, right? This is the 10 teams would go to the finals. Yeah, there's also another Israeli team down there. So actually, we thought that we would finish here, but we have some time, so I'll skip. We had some hidden slides at the end of the deck, so I think we have some time to talk about DEFCON CTF as well. So, and then I'll go back to the final slides. So since we won the CCC CTF, we automatically got qualified to get to play in the DEFCON CTF, which is the biggest attack defense type CTF. It's different. It's completely different from what we experienced before. It's, as I said, it's attack defense. It's on site in Vegas during the DEFCON conference. It runs 3 days. So basically, while it runs 3 days, it's only daytime. So starts in the morning and then ends in the evening for 3 days in a row. It has 15 teams, no prices, and the level is super, super high. So the idea with the attack defense CTF is that all the 15 teams have their own services. They start in the same state. Everybody has the same services to operate. And all you need to do is to reverse engineer those services, find vulnerabilities, attack the other teams with the vulnerabilities you found, and at the same time protect your services from being attacked. While all this happens, everybody could see everyone's network traffic, so you could steal vulnerabilities. You could see if somebody attacks you and steal a vulnerability. So and then patch it, or for example, if you find a vulnerability, you have a dilemma whether you go and attack with it, or you first patch yourself, or do both. So it's like a completely different challenge, and there are some really different skills that are needed beyond the finding and exploiting a vulnerability. So yeah, that I mentioned. And one important thing is that when you protect your service, so for example, you can add some protection mechanisms to your service, but the idea is if it becomes too slow, you start losing points. So you cannot just go and implement all the possible buffer overflow protection in your code and then just run the service, because it just becomes slow. The organizers constantly pinging your service to make sure it functions. So you, like in the real world, you need to find a balance between protecting your service and keeping it functional. So this is how it looks like in the actual CTF room. This is our table here. I think they limit the number of players on the actual tables to 8, and they really have some nice visualization when one team managed to exploit a vulnerability for the first time. So they have this first blood visuals running all over the screens there, and yeah, and the first time we came there was, I think, 2016, and that's where also the first time when they ran what's called the Cyber Grand Challenge, which is a different type of CTF run between machines, computers only, no humans involved. The humans are involved only in building those machines. And so this is also attack defense CTF. So each machine needs to try to attack other services and protect the service from the attacks of other teams. It runs for several hours. There were 8 teams, and the prize was $2 million. So this is a serious prize. So this is how it looks like. This is Vegas. They know how to put a show. And what you see here on the screen also is like the actual visualizations of the attacks. So pretty cool. Like you could actually see how each machine would try to find the vulnerability and to patch against it or to exploit it. So all the machines are here. They look like those supercomputers, they are indeed super strong. And all the arena here, all this area is fully air-gapped. The only thing that goes inside is electricity and water cooling. That's all. The operation computer inside the arena produces logs that they burn into a DVD, and there is like this robotic arm that passes the DVD to the commentators. They take the DVD, they put it in their computer and kind of show and analyze what's going on inside the arena. And so the interesting thing is that this CTF was held one day before the big DEFCON CTF, and the winner of this competition, like the machine that would win this competition, would also compete against the human teams. So the machine, this is the winning machine, Mayhem, from a company named For All Secure, and so in the actual DEFCON CTF, again, reminding you, the first time there is a machine competing against humans, and so they lost. They were in the last place, but there were some challenges that they did like best, really outplayed all the human teams, including in patching vulnerabilities, but also exploiting. So there is like some really, really crazy and awesome things to see in there. And so that's that's the Cyber Grand Challenge. And I'll jump back to the slides, and I believe we actually have some time for questions. So finally, CTFs are awesome, and This become very popular. Every conference now has them, and you don't have to be actually on site to play. Those are now everywhere, and you know, like Google CTF and many others. Actually, you just can join and play from your home. Really, an amazing place and an amazing community to engage with and learn from. So really, if you haven't ever played a CTF or solved a single channel challenge, really encourage you to do so. And we basically started our journey by mistake. Like, we didn't plan to become a real CTF team, but we really found out how amazing it is and how fun it is. So really would encourage you all to do the same. And really, this is the time to thank our amazing team. The two of us are here, but behind us is an amazing team that play with us all this time. So thank you. And of course, to the CTF organizers, creating a CTF is a tough job. It's much harder than solving challenges. And really, they put a lot of time into each and every challenge, and into creating the idea, implementing it, and then testing it, and then making sure that you don't find any ways around it. So usually, the teams that are competing, they are also the ones creating those challenges. So these are really top-notch security experts of the world doing that in all the CTFs out there. So big thanks to them. And also to all the teams that are competing, and special shout out to 5BC, the other Israeli team that we met all the time in the CTFs, and probably there are many others that we just don't know. So thank you all. And we have some time for questions. Actually, quite a lot of time. 8 minutes.
When are you organizing the Pasten CTF?
Someday.
So the question is, when are we organizing our own CTF? Yeah, someday. We know it's hard. We know it takes a lot of time, and we do play now for fun, and but definitely on the horizon to create our own CTF. So.
I have a question. When you had the link to the root directory, could download the files from this link?
Yeah.
So why didn't you download the whole SQL database?
Good question. So the question is, since we got the access to the file system of the challenge, we could just go to the var something directory of MySQL and just download the actual stores of the MySQL. And the answer is that the service runs as it's an Apache service, and it runs with the permissions of web app or web root or something like that, and it's not the permissions like we weren't root to access those files. This is actually the first thing we tried. We went to those folders and tried to take the files.
Another question: did you compete in the pros versus pros in the BSidesTLV? It's the same thing as
No.
It's assigned defense.
No.
Great.
Ask question, otherwise we'll have to drink, because
Sure.
it's coming.
Have you learned for this? Like, I don't know. Have you learned for this? Cyber stuff like that?
So we're all in this area. Like we're doing research in our work, in our background. That's what we do. But I think we never played the CTF before 2013, and there's a lot of things we learned while playing CTF. So,
yeah, one more thing to understand is the CTFs are for everyone. You have challenges for every level that you're in. So from beginners to the most advanced researchers.
yeah. So we did learn some things about how to play the CTF games. For example, it's we had some challenge where we actually didn't have wanted but didn't have the time to show, where it was a simple web challenge with some cross-site scripting, but we didn't find the cross-site scripting vulnerability, and there was some operational problem with the challenge. It wasn't running at some point. So by mistake, we took over the whole server. Like we found a different vulnerability that they didn't want us to find. And now we understand that now we had some better gut feeling of where this shouldn't happen. Because when a challenge is in the web category and it's like, you know, marked easy, and we just can't solve it, probably there is something basic we're missing and not some crazy vulnerability. So the fun thing about this crazy vulnerability we did find that wasn't intended is that the next year they actually turned it into a real challenge, hard one, and so that's when we got the score for free because we already knew it. But that's the kind of thing you learn when you play CTF. You kind of learn this, like the mindset and the things you should do and you shouldn't do while playing. So that's a skill, kind of like the muscle we develop.
And what platform do you use? Windows or Kali?
Preferences vary. IDA works well in Windows, but everything else is not. Yeah,
it really depends.
Really, we have we're quite a diverse group of people. We're around 25 people. Everybody has their own preference and machine. Yeah.
What makes for a bad challenge? The ones that you dislike.
What makes a bad challenge? Wow.
I would say that
Guy is listening.
Please do tell.
I would say that when you have to guess more than to get the information out of the server, out of the challenge, then it's really frustrating because it's really easy to not guess it right, and there are challenges like that.
Yeah. Basically, when you're not measured by your skill, but more by your guessing capabilities.
All right. So.